Okay, for the first demonstration project using Shapr3D, we're going to refer to a technical drawing, which you can find on the class page. If you tap on Content and then scroll down to Shapr3D and then down to Assignment Chord Drop, you'll see the drawing there. And we'll be using these dimensions as we recreate this drapery chord drop. These dimensions were taken from an actual existing chord drop that a student brought in. It had been chewed to pieces by her cat, and she was wanting a quick and easy replacement. So I measured the existing chord drop using calipers and came up with this basic drawing. So again, I'll be referring to this as I go through the demonstration. Back in Shapr, we'll tap Start Designing, New Design, and I'll double tap on the bottom plane and zoom in on the axis. So referring to the drawing, it looks like it's a symmetrical, essentially cylindrical body. So with that type of object, we probably want to use revolve, just to give you an idea of what revolve looks like. I'll just draw a simple shape here so I can see the enclosed area. Now actually I'm going to deselect that and choose Tools, Revolve, and the instructions say to select a face and then to select an axis around which we want to revolve. So I'll select the y-axis, and you can see that I very quickly create a hollow cylinder. And the chord drop is essentially this basic shape. So we're going to draw half of the shape, or a cross-section of it, and then revolve it around the y-axis. I'll cancel that and undo this. Go back to my top view, zoom into the axis. Okay, so from the technical drawing, we see that the bottom and top are 12 millimeters in length, and the chord drop is 26 millimeters tall. So I'll start with a sketch and start at the origin. And remember, I'm doing half here, so I'm just going to make that 6. And going up, I'll make that 26. And I'll just go over and down, and I've got my basic bounding box. Now, if I look at the drawing closely, you'll see that it bows out a bit near the top. So it's actually wider than 12 millimeters. And I can see that from the drawing at the top, the circles. It says the outer radius is 8.22 millimeters. So I'm going to draw another line here. 8. That's the radius. Yep. Okay. So I do not need to cut it in half. 8.22, then down and over. Okay, so that outer vertical surface should be the boundary of that bulging curve. Before I go any further, I'm going to tap all of the, do it in this order, I'm going to tap all of the points to select them and then type lock at the bottom. Looks like my line got erased there. Okay, so these lines or points won't move around accidentally while I'm continuing with the drawing. So the next piece is, where is that bulging occur? So again, from the technical drawing, we see that looks like there's a straight diagonal line that goes up to a certain point from the bottom, and same from the top, a straight diagonal line that comes down from the top. But then there's an area where those two lines are joined by a curve. And I know how much space, what the distance is for each of those straight diagonal lines. So 18.62 is one. So I'm going to start from the bottom, and 18.62. Okay. And I'll go ahead and lock that point. And down here, this one is 2.86. All right, and so that curve happens somewhere in between there. So there's a couple different ways I can do this. With this particular part, absolute precision is not needed, so I'm going to do a sort of quick and dirty way of doing it. I'm going to draw another line connecting those points, and you'll see there's a midpoint, the blue dot there, which gives me roughly a point to shoot for. So I'm going to create a diagonal, those two diagonals going from there to there. Now you may be saying, what about the curve? So this is my plan. And there's no one way, one correct way to do this, right? There's infinite number of possible ways you could recreate this object. We're basically reverse engineering this chord pull. So just to give you an idea of what I'm shooting for here, I'm going to use revolve, and I'm going to choose those two, and then the y-axis. So you can see I've already got the rough shape here, and that might be good enough, but what I can also do is fillet that to round it off and make it even closer. Now if you look in, if I go top view, you'll see that the bulging area is a little bit less than the outer boundary box, so a fraction of a millimeter, but I think again for this project that'll be good enough. So I'm going to undo, go back to my drawing, my sketch. So what do we have left? We need to create the interior of this object. So you can see there are holes of two different diameters that meet almost in the middle, if you're looking at the cross section on the technical drawing. So the idea here is that the cord from the drapery will enter through the skinny hole and go all the way through the cord drop. You tie a knot in the rope in the cord and then pull it back up, and that larger diameter cavity hides the knot that you tie in the drapery cord. And so if you think about it, our drawing is actually upside down here, which is fine. So again, from the drawing, we can see that the small hole is 3.5 millimeters in diameter. So we want it to be 1.75 radius. I didn't take Let's try this again. I'm going to lock that point in just so nothing moves around on me. So again, I'm going to zoom in quite a bit here. All right, 1.75. There we go. And I'm going to go ahead and lock that. All right, because 1.75 is half of 3.5. And it is, that skinny hole is 12 millimeters in length. So start a line up here. If you don't automatically make it horizontal, or you're not confident, or excuse me, vertical, or you're just not confident that it is perfectly vertical, you can tap on the line and over on the right hand side choose horizontal vertical constraint, and it will keep that line perfectly vertical. And again, from the drawing, we know that that is 12 millimeters. Okay, I'm going to go ahead and lock that point. And similarly, at the top, we know that the larger hole is 9 millimeters in diameter, which is 4.5 in a radius. 0.5. I'll lock that. Start a line down. Make sure it's a vertical. And that one is 13. Okay, and I'll lock that. So you see there's, obviously, we know that the full length is 26. 12 and 13 adds up to 25. So there's a 1 millimeter difference between those, separating those 2 points. And if you zoom in on the technical drawing, you'll see that there's actually a fillet there, a rounded surface. So we can, and we know that it's 1 millimeter in diameter because that's the difference. So I'm just going to do this quick and dirty here. Horizontal, going to extend that line down, vertical. Now if I go in 1 millimeter and go, oops, undo that. It's wanting to jump to that point. Okay, so I'm going to zoom in, undo. Okay. Make sure that that stays and that that is locked in. So I'm going to start a line down here, make sure that that's vertical, horizontal, and then I'm just going to drag it past here. Now I can use the trim tool to trim that excess, and then use a circle starting from this point, going straight down or across. So you'll see I have a circle of 1 millimeter radius. Now I can use the trim tool and get rid of that circle and get rid of those lines. And you can see I've got that 1 millimeter radius fillet on the inside there. Okay, and that's looking pretty much complete, I think, at this point. So let's go back to Tools, Revolve, select the shapes that I want to revolve, the axis, in this case the y-axis, I want to revolve around, and done. So that's pretty good. The only thing left then is to tap on that edge and pull it out a bit. Let's see, I'll tap top so I'm looking straight down. Again, you know, it's not precisely the same as the original, but it's very close. So if I can go into the items menu and hide the sketches, and I can, down on the bottom right hand corner, there's an icon that looks like a slice of cheese, a wedge of cheese. If I tap on that, it gives me the cross section, and that looks pretty much like what we want. So from this point, at the top of the screen, tap Export. The second option, 3D Print. Then the first one, STL, give your file a name. Okay, continue. And in this case, I will share it to my MacBook. All right, close. And then the next step will be to open FlashPrint, import the file that I just exported, slice it, and print it on the printer. And then share my results on the class discussion board.